Right. So welcome to our 2 minutes with a mic session. This is absolutely my favorite part of the day. I am Teresa Gibson and I will be hosting this session today. I'm the executive director for the North Carolina Science Fair Foundation, and I am really excited to hear from our young researchers today. I did go ahead and get the recording started just a moment ago. And what I'm going to do is talk to you a little bit before we get rolling about how this will work. So if you've been in the live sessions this morning, I hope that you enjoyed them. And I want to congratulate all of our researchers. My understanding is that the judging has come to a close. So congratulations on your accomplishment. I hope you had a wonderful morning and enjoyed sharing your research. The way the session will run is a little different because in this session, our lead speakers are you, our young researchers. And so what we have done is set up the room so that you can mute and unmute yourself. And we're going to talk just a little bit about what that will mean because there are many of us in the room today. We're going to have some good rules for how we're going to be courteous to each other as researchers. And we're going to go through these kind of quickly because I know you all are professionals. But because you have the power to mute and unmute yourself, I'm just going to ask you to please remain on mute unless you are the person presenting. Once we get rolling, it will go fairly quickly, and we want to make sure that every researcher has their chance to be heard. We want to make sure everyone in the room can hear everything that's happening. We are going to do 2 minutes with a mic, and I will keep track of time. And so I'm just going to ask that you respect the timer. And by that, I mean when your 2 minutes is up, we're going to ask you to make sure you wrap up your timing and pass the microphone to the next researcher. And I will help to make that possible for you. And so I will jump on the microphone and let you know when you're running out of time and ask you to wrap up your research summary. We do want you to cheer for each other in the chat. We know after this very unusual year, you're quite expert at using these online platforms. If you haven't found the chat yet, just mouse over the bottom of your screen. There's a chat there. You can congratulate each other, cheer in the chat. You can also ask each other some really good questions. And you can use the reactions button too. And parents, grandparents, aunts, uncles, you're most welcome to cheer in the same way. And always asking good questions. This is how we get to our new and next best idea to research. And so feel free to drop questions to each other in the chat. That feature is there for you to talk with each other, and we want you to take advantage of that this afternoon. How will we pass the microphone? If you've seen any of the other 2 minutes with the mic sessions, you'll be kind of familiar with this process. But what I have done is sent out a schedule. We're going to go in order of that schedule. It's an estimate, so you might not be going at the exact time on there, but it'll be fairly close. Between each researcher, I will pull up a slide that looks much like this. It will have the project name, the category, and the researcher or researchers that are on that team. And at that point in time, the person who just wrapped up will press the mute button. So we're going to want you to look like this. And then the person who's up next is going to unmute and jump on and get ready for theirs. I will talk to you throughout and let you know, like, are you ready for me to start the timer? Once you're ready, we'll start your 2 minutes and you will get that time to share. You will not have to worry about screen sharing. I will show your quad chart that you submitted for judging. Right after you tell me that you're ready to start, we'll make sure we have the right quad chart pulled up and you will be the speaker. So I will mute myself and pass you the microphone and you can tell us all about your project this year. So before we jump into project sharing, I just want to pause and see if anyone has any questions. So you are welcome to drop a question for me in the chat, or you can jump on your microphone right now is an appropriate time to unmute and ask a question. Sometimes you have a question and other kids are also wondering the same thing. So if you have one, I hope that you will drop it into the chat for us today so that we can get started with everyone knowing what we want or what we're going to do and what to expect throughout the session. All right, well, if new questions pop up along the way, then we can address them as they come up. But you do have the same schedule as I have. There have been a couple of changes, kids who couldn't make it this afternoon. If we run into a research project where the researcher isn't on right then we will move on, and I will try to put them later in the day to give them the opportunity to present. We want to make sure everybody gets their 2 minutes with the mic who signed up to do it. And so with that, I think you all probably know like who's next, but I am going to move us into our first project. So our first project is stay at home with less air pollution. And this is our quad chart. Is our young researcher ready to present? I thought I saw Jaden on here. I did. All right, Jaden, can you?
I'm ready.
There you go. Perfect. All right. So when you get started, I will start my timer. I will mute.
Okay. Hello, my name is Jaden Cho and I'm in 5th grade. My research project is about reducing air pollutants while cooking at home. One day, my mom was cooking and the fire alarm rang. I learned that day that air pollutants such as carbon monoxide is released by using a gas stove while cooking at home. Also, due to the COVID-19 pandemic, more people stay home and cook more, so I wanted to find a way to reduce these air pollutants so people could stay more safe at home. I had 2 parts of my experiment. For part A, I boiled water for 30 minutes without ventilation and let it rest for 60 minutes with ventilation. For part B, I did everything the same, except I turned on ventilation the whole time. I measured the level of carbon monoxide, formaldehyde, and total volatile organic compound every 10 minutes, and I used a range hood, inflow mode of the window fan, outflow mode of window fan, and had my window open as my ventilation devices. The results were that the carbon monoxide level was decreased by half when turning on ventilation while cooking. The level of formaldehyde was similar to the trend of carbon monoxide, but I noticed it was harder to get rid of in the air than carbon monoxide. The level of total volatile organic compound only went up to 0.3, and it did not have a big effect in the air quality. The level of these air pollutants can be impacted by factors, but in my experiment, the range hood is most effective when cooking, the inflow mode of the window fan is most effective after cooking, and turning on ventilation while cooking is extremely important to reduce the level of air pollutants. Thank you for listening.
Great. Thank you so much for sharing. I learned a little bit about my own kitchen. All right, with that, the next project is Quiet Please 2.0. And so I'll give just a second for our young researcher to jump onto the microphone and let me know that you are ready.
I'm ready.
Okay, wonderful. Thank you, Erica. Let me make sure I've got the right quad chart for you. Yep, perfect. All right, I will start my timer when you tell me.
My project is called Quiet Please 2.0, and this year my class is in the gym because of COVID, and 2 4th grade classes can be really loud. My school hung up curtains to make it quieter, and I was curious if it actually worked. In my experiment last year, I tested the same sound in 3 different spaces: a bedroom, a bathroom, and outside. I learned about absorbed, reflected, and dissipated sound, acoustics. I used that information to build on for this year. My question this year is if you can make an enclosed space quieter by adding soft items. My hypothesis is that adding more soft items to an enclosed space will make sounds quieter. For my experiment, I took all the soft items out of my bathroom, including myself, because I am also a soft item. I measured the sound in the room with no soft items as my control. A stronger control was something the judges suggested last year. I hung up 1 through 6 towels and tested each 3 times. I put the data from my chart with the average dB and the area of towels into a graph. The results from my experiment showed that 6 towels was the lowest test measurement, which was 85 decibels, which is about as loud as a garbage disposal, and no towels was the highest test measurement, which was 104 decibels, which is about as loud as a jet flying over at 1,000 feet. My hypothesis was proved correct. Adding more soft items does make an enclosed space quieter. So my school could add more soft items to the gym to make it even quieter. Thank you.
Great, thank you so much for sharing. I hope you'll share that information with your school. Our next project is Towels to the Test. And so we have a physics and math project. Do we have our young researcher ready?
Yes, ma'am.
Okay, great. So I will start my timer once you are ready to talk. Oh, wait, I'm sorry. Let me make sure I pull up your chart for you. Okay.
Good morning. Good afternoon, everyone. I'm Eliza Rouse. I'm from Pink Hill, North Carolina. My research question was, what paper towel is most absorbent? I became interested in this topic when COVID started, when you couldn't get the paper towels you liked, and you had to buy different kinds of paper towels. And I wanted to test which paper towel is most absorbent. To test my experiment, I took 6 different brands of paper towels and I put them in water, and I took it and I squeezed all the water from the paper towel into a separate bowl, and I poured all the water in the bowl into a graduated cylinder to measure. My results were that the Viva paper towels had 45.5 on average, and the Scott paper towels had 18.2 milliliters on average, putting Scott in last place. My results did not agree with my hypothesis. I thought Bounty paper towels would be most absorbent because they are 2-ply, most awarded, and have special design stitching to help trap water. And the Viva paper towels are 1-ply, soft and thin. I could improve my experiment by testing the strength as well as the absorbency.
Great. Thank you so much for sharing this afternoon and for doing your research. All right. With that, remember, if you have questions for each other, you're allowed to drop them in the chat so that all of our researchers will stay on the session and you can ask each other questions in between. All right, our next research project is mask on, mask off, the effects of wearing a mask on oxygen levels. And I just need to hear, is our young researcher on and ready?
Yes, I'm here.
Wonderful, thank you. Let me pull up your quad chart and I will pass you the microphone.
When COVID-19 spread across the globe in early 2020, people posted on social media that when they wore masks, they were feeling hypoxic, getting dizzy, and feeling like they could not breathe. I wondered if this was true or not, and to answer the question, I wanted to do a study to see if wearing a mask can make your oxygen levels decrease. Friends and family were invited to participate in the study. The participants were 20 years or older in age, and none had respiratory diseases. Each participant signed a consent form and was given a 3-ply disposable non-medical face mask to wear. The study was done with COVID-19 precautions. For the first 5 minutes, I explained the instructions to the participant. For the next 5 minutes, the participant and I kept our masks on and we stayed 6 feet apart. I checked their oxygen levels at 1, 3, and 5 minutes on the pulse oximeter. During the last 5 minutes, I left the room and closed the door. The participant took their mask off. They recorded their oxygen levels at 1, 3, and 5 minutes on the pulse oximeter. In my study, I had 20 participants. 13 of my participants' oxygen levels stayed the same, did not decrease. My 7 other participants' oxygen levels did decrease, but did not decrease 3% or more, which is considered clinically important. Based on previous research, it was shown that an oxygen level decrease of 3% or more is considered clinically important. Overall, in the study, wearing a mask does not make your oxygen levels decrease in a clinically important way. This means that people can breathe just as well with the mask on as they can without one. My research disapproves the idea that wearing a mask decreases your oxygen levels or makes it difficult to breathe. I hope to encourage people to wear a mask because they protect you from COVID-19, but do not negatively impact your breathing.
Excellent. Thank you so much for sharing this afternoon. Wonderful. Okay, our next project is Splish Splash Portable Hand Washing Station. And this is an engineering and technology project. Sorry, said the wrong category. Is our young researcher ready?
Yes.
Wonderful. All right, I'll start the clock when you start talking. Oh, let me pull up your quad chart. I keep forgetting that. There you go.
Hi everyone. Have you or your family ever been somewhere with dirty hands and no water or soap nearby? Maybe hiking at the park? Well, I just changed that. My name is Noah Gelb and I invented a portable hand washing station. Splish Splash allows you and your family to wash your hands on the go and wherever you are. Want to use it at sports games? Check. Want to use it while camping? Check. With COVID-19, I think we all know the importance of hand washing, but let me spend a minute telling you about Splish Splash. It fits in your car, there's no trash, it's gentler on your skin than hand sanitizer, and doesn't everyone like the feeling of clean hands? I started by drawing my original design on paper. Then I built a box out of plywood because it's a light and thin wood. I assembled the components, which include 2 bottles, a funnel, a faucet, soap, an air pump, wires, a button, a battery pack, and a doorknob. I connected the full water bottle to the 2 tubes with the other ends going into the air pump and the faucet. When I push the button on the top, air is forced into the full water bottle using 1 tube and water is pushed out of the other tube. The water comes out of the faucet through the funnel and into the empty water bottle. When I'm finished, I empty the dirty water bottle. That's what you call clean, portable, and efficient.
Great. Thank you so much for presenting. All right. Our next research project is Got Milk, Get Plastic. Is our young researcher on?
Yep.
All right, wonderful. Welcome. I will pull up your quad chart and pass you the microphone.
Hi, my name is Arash Shimokin, and my project is called Got Milk, Get Plastic. My hypothesis for this project was, can you make plastic from milk by adding vinegar? Will adding more vinegar make more plastic? My procedures for this project was to first label 4 cups, 1, 2, 4, and 8, and poured that number of teaspoons of vinegar into each of those cups. And I microwaved 4 cups to 120 Fahrenheit, and I poured 1 cup of milk into each cup of vinegar and stirred. I recorded my observations after 10 minutes. I slowly drained the liquid from each of the cups into separate mugs covered with cloth squares. I collected casein from each cup and weighed with the kitchen scale and recorded the weight of casein. Repeat steps 1 through 4 two more times. Mix casein with food dye and glitter and mold it into the shape you want and let it dry. And this is what I made. And my conclusion was you can make a plastic called casein from milk and vinegar. The cups with more vinegar produced more casein. The average amount of casein made was 17 grams for cup 1, 45 grams for cup 2, 51 grams for cup 4, and 68 grams for cup 8. The way that casein plastic could help people is that if people don't have the money or machines to make plastic, they can make their own plastic. Thank you.
Wonderful. Thank you so much for sharing. All right. With that, we will bring up our next research project. Oop, I apologize. Elephant toothpaste. Are these 2 young researchers on? Looking for Colin. Not sure. I don't see Colin. All right, I will pull that one back up. Again, I'm going to just make a little note here so that I don't forget to bring that back up in case they're able to join us. All right, next up, is it really Nerf or nothing? And do we have our young researcher ready to present? I love all the cheering in the chat. Y'all are fantastic. I'm seeing someone with this last name. This is Eli Shepard. Is he on yet?
Yeah, I'm on.
Oh, perfect. Wonderful. I thought I saw someone. Okay. All right. Let me pull up your quad chart. and I will pass you the mic.
Thank you. Today I'll be showing you my science field project. I'm a 5th grader at Mountain View Elementary School. So why I did this project is, I've loved Nerf guns for a very long time. I've want to do a project like this, and I wanted to test if Nerf guns actually shot as far as Nerf claim they do. So what we did is we got in a building with a very long hallway, and we turned off all the air conditioning, and we taped the floor down every 10 feet, and we got a chair and turned it around backwards to put the blaster on the back. Then my dad put a label on the top of the gun that said we know it's shooting straight. Then we shot each gun 10 times to warm up the spring. Then we shot it 10 times and recorded the results. The Han Solo blaster it claimed to shoot up to 70 feet. The farthest was 43 feet. It shot by 27. The average was 35.5 feet. The Zombie Strike Hammer shot claimed to shoot up to 55 feet, but the farthest was 44 feet. It shot by 11. The average was 38.8. The Mega Magnus blaster claimed to shoot up to 65 feet. The farthest was 63 feet. It shot by 2 feet, with an average of 51.6. And even though the Nerf guns did not shoot as far as they claimed they do, they are still one of the better brands of blasters out there. But just know that they might not be the exact distance that Nerf claimed they do.
Great, thank you so much for sharing. I feel so happy that today I've learned so much as a consumer about what I should think about the marketing that I am reading. All right, with that, we will pass the microphone to our next project. We have Why Do We Get Dizzy? Is this young research team on the call, on the session? I'm looking. Okay, I don't see that name popping up. All right, I will hold off on that and we will see. I'm going to just make a note to pull it back up in case we get them pulled up later in the afternoon. All right, so we're gonna set this one aside for a little bit and see if we have this team on. Do we have, what is the hardest rock or mineral? Is this Solomon and Chase? We see these folks on here? All right. Perfect. And then our next project, I know I'm just going to move through the quad chart because these two young researchers need to be moved to the second session. So I'm going to move this group to the second session for us to hear their presentation just after the break. And then I know I saw this young researcher on here. Do emotions affect your performance and learning capabilities? Do we see this young researcher on here?
I'm here.
Yes, wonderful. All right. So with that, I will pass you the mic.
Hi everyone, my name is Shubhi Gupta and I'm from Greensboro Academy. My project title is Do Emotions Affect the Performance of Your Brain and Learning Capabilities? I chose this question after watching the movie Inside Out, in which the performance of the girl Riley were affected by her emotions. I did some initial research on this project and found out that emotions activate various parts of your brain. I wanted to test this with scientific analysis. For that, I made 2 IQ tests. They had the same pattern and number of questions. I gave the test to a few of my friends and asked them to complete one in a positive mood and one in a negative mood. But controlling emotions can be difficult, so I gave them a few suggestions. After I got the tests back from them, I evaluated them across 2 parameters: time taken to complete the test and score of the test. The average time taken to complete the test in a positive mood was 5 minutes less than it was in a negative mood. And the average score by the respondents in a positive mood was 44.1, which was 4.4% higher than it was in a negative mood. That proves that my hypothesis was correct. Emotions do have a big impact on our brain. There's a biological reason for this. It involves blood and chemicals in our brain. There are learnings for everyone here: students, parents, educators, and society. Emotions are powerful. We will always have a mix of emotions, but my recommendation is that we should let positive emotions outnumber the negative ones. Thank you.
Great, thank you so much for sharing. All right, we did have a couple project teams that weren't on the session yet because we're a little bit ahead of schedule. I just want to check in to see if we have the elephant toothpaste group back with us. We have, that's Colton and Colin. Okay, they're not on yet. All right, what about McKenna and Grayson? Why do we get dizzy? No? And Solomon and Chance? I know that was just a moment ago, so maybe not. Okay, all right, then what we're going to do is we are going to shift to a break. I am going to honor that 1:10 time because that's what the parents for the next group got, and I don't want them to miss it because I start early. So what we will do is we will just take a little break. It looks like it's going to be about 20 minutes. We will start again at 1:10. So welcome to our researchers presentations, 2 minutes with a mic. Really excited to continue these sessions this afternoon. My name is Teresa Gibson, and I am going to get us started with just a little bit of information about how we can be courteous to each other as we share. The difference between this session and the other live sessions is that in this session, you all have access to your microphone because we want our young researchers to be able to jump on and share. It's really great, but we just want to make sure that we set some norms so that we can all respect each other and hear every researcher. So the first one is to please stay on mute unless you are the one presenting. This way we'll be able to hear all of the great projects and research results that we have to learn about this year. As we go through the session, we're going to give each researcher or research team 2 minutes with the microphone, and I am the person who's keeping track of the time. Just going to ask that if I jump in and let you know your 2 minutes is up, if you would just quickly wrap up so that you are giving your peers and colleagues their chance with the microphone too this afternoon. Next, we want to think about cheering for each other. You've all done a lot of really hard work this year and a lot to get to the state level competition. And so congratulate each other and cheer for each other in the chat. This is all great work and we want to cheer each other on, and you can use the reactions too. If you mouse over the bottom of your screen, you'll be able to find those reaction buttons. And then, as always, we're going to encourage you to ask good questions. It's really, really important as researchers that we ask each other good questions, push each other, and help everyone to start thinking about that new and next research question that they might have for upcoming years, to keep us learning and to keep improving the world. And with that, just a little bit about how the session will work. You do have control of your microphone, so I will show the project title and then display the quad chart during that time. What I'm going to ask of you is if you just finished speaking, please do click this and make sure that you are seeing a muted button for yourself so that we can pass the microphone. I will help facilitate that. I will give you instructions along the way. I will say I'm going to now pass the mic. So that means one researcher is going to be muting and the next researcher up is going to be unmuting and just saying, hey, I'm here, I'm ready to present. If at any point throughout the session, if it's your turn to present and I don't have the right slide up, go ahead and say, Miss Teresa, I need a different slide, that's not me. All right, let me know. So as we jump into this afternoon session, I did send you all a schedule. I know that we have that first researcher, Charlotte, sitting and ready. I can see you, but I am going to offer an opportunity. We had a we were a little ahead of schedule in the first session and we had a couple of teams miss their time slot. So I have a couple of teams that are going to go before you, Miss Charlotte, if that is okay with you. Wonderful. Thank you for being flexible. And so with that, I am going to pull up that first opportunity. This project is what is the hardest rock or mineral? And I believe I've already spoken with this young researcher. So Solomon and Chance, are you all ready?
Yeah.
All right, let's wait till I hear Chance. You good, Chance?
Yep.
All right, with that, I will pass you the microphone. Oh, let me pull up your chart. This is your project. All right.
Hi, and so this is our project called "What is the hardest rock / mineral?" and it's about what our hardest rocks we had were, and this is our Play-Doh rocks, and so we did a couple of different tests. And yeah, so but first we made our hypotheses. So my hypothesis was green aventurine would be the hardest, and quartz would be the second hardest, amethyst would be the third hardest, geode would be the fourth hardest, unknown rock would be the fifth hardest, and chalk would be the sixth hardest, and those were our things. And yeah, Chance can say the next part.
So we made our hypothesis. Mine was quartz, then amethyst, then green aventurine, then geode, then unknown rock, and then chalk. And then Solomon, you can say it.
I already said mine, and so yeah, and so we numbered A, B, and C, and D, and E, and F, and quartz was A, geode was B, amethyst was C, green aventurine was E, green aventurine was D, E was unknown rock, and F was chalk. And so we did a project on this. We scratched them with things of known hardness, our fingernails, copper, and steel nail, and 4 of them, which are the first 4, were all harder, and the last 2 were shorter. And so this one wasn't scratched by the fingernails, but the other 2. So this was the 5th, and the other one was the 6th. And but they were tied, and we didn't want to do it, so we went on to this next test that Chance can tell us about.
Okay, and Chance, I need you to be pretty quick because we're out of our 2 minutes. Okay.
Okay, so basically we scraped each mineral against each other, and quartz won all of it, I think.
Amethyst was second, and it was basically Chance's hypothesis. So yeah, those were our results. And yeah.
Right. Excellent. Well, thank you, gentlemen, for presenting and sharing your research this afternoon. Our next project up is Why Do We Get Dizzy by McKenna and Grayson Dickey. Are our young researchers on? I saw you all right before break. Oh, there you are. Great. All right, let me pull up your quad chart. And I'll start the timer as soon as you're ready.
Okay. So the reason why me and McKenna wanted to do research about dizziness is because we both do sports that involve spins and flipping. I do skateboarding and McKenna does dancing. Our main research question was, why do we get dizzy even with our eyes closed? We had 4 volunteers, 2 doing chair spins, and 2 doing belly turns 3 times eyes opened and 3 times eyes closed. Each after they spinned, we asked them how dizzy they felt on a scale from 1 to 5. at 1 being not dizzy and 5 being really dizzy. We recorded the number of seconds their pupils were moving.
We learned that not everybody feels the same amount of dizziness. The boys got dizzier with their eyes closed, but they had long eye jiggles, and even after you stop spinning, you still feel dizzy because the fluid in our semicircular ear canals is still moving, but our eyes say we are not moving, and the brain gets confused, and this causes us to feel dizzy. We learned that this helps acrobatics, ice skaters, astronauts, dancers like me, and skateboarders like Grayson. Dancers butt their heads to not get dizzy because I do it in dance and it works.
Great. Thank you so much for sharing your research and what you learned from it. Excellent. We have one more team up from prior to the break that needed a shift. And so the Sweet Mystery of Halloween Candy, do we have these two young researchers on yet? I'm going to look because I just, if not, oh, we do. Okay, perfect. Great. All right. So let me pull up the chart and I will start the timer when you are ready.
Okay. Hi, my name's Avika Sheth, and my name's Akti Sheth, and we're in 3rd grade, and we go to Barringer Academic Center in Charlotte, North Carolina. And the name of our project is The Sweet Mystery of Halloween Candy. So you know how parents and dentists are always telling us kids we can't eat Halloween candy. But why? We only get it once a year. We think that Halloween candy and sweet fruits taste the same, so they should have the same amount of sugar. And we did a project to see if that was true. We couldn't get candies from 2020 because of COVID-19, so we went back to our 2019 candy chart, and we chose the 15 most candies we got that year to use in our project. Now I'll hand it on to Ugly. Okay, now to our results. We found that most candies we used had more sugar than the fruits. But surprisingly, Swedish Fish has less sugar than strawberry. Now to our conclusion. Candies have more sugar than fruits, so it's advisable to eat fruits, but you can eat candies once in a while. Thank you for listening.
Thank you so much for sharing. Excellent. All right, so I will help to pass the microphone. Our next project up is what tea makes the best invisible ink? So thank you, Charlotte, for being flexible with your schedule. It is your turn. Let me know when you are ready.
Okay. The goal of my experiment is to find out what tea is best suited for invisible ink. I am testing 3 different types of tea: black tea, green tea, and barley tea, and I'm using a tannin compound as control. Tannin doesn't have an intense color, but when iron sulfate is applied to tannin, it forms a strongly colored compound. My hypothesis was that black tea would make the best ink because it's darkest and I think that it has the most amount of tannin. For my procedure, I brewed 3 different types of tea, wrote messages on the paper using the teas, let them dry, and applied iron sulfate to the paper. When the iron ions in the iron sulfate mix with tannin, it forms a strong color. After about 5 minutes, the tannin control was the most visible or darkest, followed by the black tea, and then the green tea, and the barley tea was not visible. My hypothesis was correct. Black tea makes the best invisible ink after tannin. It goes on clear when you write the message, and then the person who is receiving the message needs to apply iron sulfate or a solution that includes iron sulfate to reveal what I've written.
Great. Thank you so much for sharing. Excellent. All right, we will move on to our next project. Next one up is, how does a chick breathe inside its shell? Do we have this young researcher on?
Yeah, I'm on.
Wonderful. All right, so let me pull up your chart. And I will start your timer whenever you are ready to share.
Okay, so hello, my name is Anshika, and my research question was, how does a chick breathe inside its shell? My hypothesis was that eggshells have tiny microscopic pores that can let substances go through them. So how I did the procedure
is I got some water and I put 1/4 teaspoon of liquid detergent and 1/4 teaspoon of blue food color. And then I put the eggs in there and let it sit there for 24 hours. And then I inspected the inside of the shell. And the one that got the best result was the one I put it in detergent A, water and dye. It had tiny blue dots near the bottom of the egg. And my conclusion was that my hypothesis was right. The egg does have pores that let oxygen in and carbon dioxide out. And this is supported by the fact that there were tiny blue speckles near the bottom of the egg. And that's it.
Great. Thank you so much for sharing. I bet there were lots of people curious about that one. All right. And I love seeing all of the cheering in the chat, y'all. Keep it up. Keep cheering each other on. It's fantastic. Okay, we're going to move on to our next project. We have reducing contamination in wastewater. I believe I saw this young researcher pop up on my screen. Divya, are you here? Oh, you're just muted.
Yes.
There you go. Perfect. All right, let me grab your quad chart for you. All right, and I will start your timer when you are ready.
Okay, I'm ready. My project is about reducing contamination in wastewater. Wastewater is used water. It has human waste, food scraps, oils, and soaps in it. Wastewater comes from residential and industrial usage. 20% of residential wastewater comes from a shower or bath. An average shower uses up to 35 to 42 gallons of water. The population in America is 331 million. So every day for a shower or bath in America, we use 11.5 billion gallons of water. My project's main focus is to reduce contamination in that 20% of water. How do we do that? By using soap products that contaminate the water less when taking a shower or bath. My question is, among herbal bath powder, Olay body wash, and Harris Teeter body wash, which body wash contaminates the water less? My hypothesis is that bath powder contaminates the water less. In my background research, I found out that herbal bath powder is made out of natural ingredients the human body can consume. But the body washes have many chemicals in them. This supports my hypothesis. I use TDS to measure the contamination in wastewater. TDS, or total dissolved solids, is comprised of inorganic salts like calcium, magnesium, potassium, carbohydrates, sodium, chlorides, and sulfates. It also has a small amount of organic matter that's dissolved in the water. When I started this project, I considered TDS as my dependent variable and the bath powder and body washes as my independent variable. The procedure is to mix each product in 3 glasses with the same amount of water. Then, using a TDS meter, I tested the TDS. I did 2 trials. Both my trials showed the same results. Bath powder had the lowest TDS and Olay body wash had the highest. So my conclusion is that my hypothesis is correct. In a wastewater treatment plant, soapy water is treated and sent down to lakes, rivers, or streams. Some treatment methods are better at removing phosphates than others. Not all the phosphates are removed. One thing I would recommend is to cut down the use of phosphorus soaps. Instead, we can use natural products like bath powder for skin and soap nuts for hair, etc. One last thing I would suggest is prevention is better than purification. This can save millions of dollars and time on water treatment. One more thing I would like to point out is when the phosphates in the soapy water are not treated and sent down to lakes, rivers, or streams, the wastewater will evaporate and then form a cloud. Then when it rains, it can rain acid rain.
Great. All right. Well, thank you so much for sharing. That's excellent information. I definitely learned some things listening to you. All right, our next researcher or our research team for fixing flooding. Are we ready and on the line?
Yes.
Excellent. Okay, let me just pull up your chart. Great. And I will start the timer when you're ready.
Our project was fixing flooding, and our goal was to prevent flooding and see which design would work best. Natural things or a water wall would best prevent flooding. Plan A was a water wall, and I used clay, popsicle sticks, duct tape to make my wall, and then put it against my house and put a pool of water in and used a fan to blow it against the house like waves.
Mine was Plan B, and I used sandpaper, plants, aluminum foil, glue, and popsicle sticks. I made a house out of popsicle sticks, and I built a ramp, and I put fake plants and sand dunes made out of sandpaper and aluminum foil on it to try to prevent the water from reaching the house. And both designs prevented flooding, but Plan B worked better because some water went over the wall in Plan A, but no water reached the house in Plan B.
Great, so interesting. Thank you, ladies, for sharing. Our next project up is slime time. Is this young researcher on?
I'm good.
Great. All right, so let me pull up that quad chart for you, and I will start the timer when you're ready.
I'm ready. Hi, my name is Sayal. I'm a 5th grade student of New Charter School. My project about slime and I titled it Slime Time. Who among the kids of my age just like slime? Slime is an icky, sticky, and slimy substance that kids love to play with. Slime making caught my attention, so I decided to create 4 different types of slime. I made slime with its basic materials and using additives to make different slimes. Fluffy slime is made out of shaving cream. Magnetic slime with the use of iron fillings. Glow-in-the-dark slime with glow-in-the-dark paint. And glow-in-the-black light slime with the use of tonic water and glow-in-the-black light paint. I measured its properties by thickness, stretchiness, heaviness, and bounciness. Then I identified the best slime by ranking the slime according to 1st, 2nd, 3rd, and 4th. I ranked each slime according to 1 being the best and 4 having the least of its properties. The slime with the lowest total is considered as the best slime. The result of my project showed that the magnetic slime is the best slime that I made, as first rank of bounciness and heaviness, and second on stretchiness and thickness. Glow-in-the-black light came second, being in its stretchiness. Fluffy slime came third, and being best in its thickness. The lowest ranked slime I made was glow-in-the-dark slime, having the least of its properties that I made. If I'm going to make my slime project again, I will measure its properties once again after being played and stored for months. I think this will help support and confirm the rankings of the slime I made. Thank you.
Great, thank you so much for sharing. All right, our next project is reasons for vision problems in kids today. Is this young researcher ready?
Yeah.
Excellent. Let me just pull up your quad chart for you. Okay.
So my project name is Reason for Vision Problems in Kids Today, and the reason I chose this project is because last year in August I got glasses and I was watching a lot of screen, so I made my hypothesis that too much screen time causes vision problems in kids. And after that, I made a questionnaire of 10 questions on a platform called SurveyMonkey with my parents' help, and I anonymously distributed surveys to children and their parents. I made sure not to only get the opinions of the children, because they would give answers like screen time does not cause vision problems because they watch a lot of it, so I got the parents' answers too. I collected 84 responses to my survey, and I organized and spread the data by putting it on Google Sheets and then printing it. The type of questions I asked is if anti-glare glasses helped, or if timely eye checkup helped, or how often you get eye checkup, and And yeah. Based on the 84 respondents of sample data I collected, I got to conclude that my hypothesis was correct and screen time does have an impact on eyesight. But I think that I should have collected more data and gotten more respondents. So if I got another chance, I would probably do that.
Excellent. I hope you do a continuation project next year then. I look forward to hearing about it. Great. All right, our next project up, what type of beverage container keeps the water the coldest? Do we have, I think I saw this young researcher. Oh,
I'm here.
Yep, there you are. Wonderful. Okay, let me pull up your quad chart for you. And you are good to go.
Okay, so my name is Joshua Stroud, and I am in the 5th grade at Pink Hill Elementary School in North Carolina. And my project title was, what type of beverage container keeps water the coldest? So my hypothesis was that if the stainless steel beverage containers had the extra insulation in the thermoregulation, the water inside would be cold no matter what the outside temperature was. So first what I had to do was I had to get 8 beverage containers. I have 2 right here. This was the one that was the best, and this was the one that was the worst. And so I took 8 beverage containers, 1 styrofoam, 4 stainless steel, 2 plastic, and 1 glass. And so then I added 20 to 24 ounces of water each and about 10 ice cubes in each. Then I took a digital cooking thermometer and I measured the water's temperature over different time intervals from the start to 1 hour, 4 hours, 8 hours, 12 hours, and 24 hours. Then my conclusion was that my hypothesis was correct, and that stainless steel beverage containers kept the water the coldest because of the extra insulation with the thermoregulation. Some other ways that I could have tested was like which beverage container keeps drinks the warmest, or which beverage container keeps water the coldest outside on a hot day.
Excellent. Thank you so much for sharing. And I'm curious about that warm one because I'm a warm drink person. So I'd love to hear more if you do that research. All right, our next project up is plant-based renewable energy. Do we have this young researcher ready? Gabriel? All right, what we will do is we'll just make a note and we'll see if Gabriel's able to join us a little later. We can come back. All right. So the next one is don't burn the cookies. Is this young researcher ready? Yeah, I see you.
Yes.
There you go. Perfect. All right. That's your quad chart. So we are ready to go whenever you are.
My name is Braxton, and we always cook cookies, and we always like to we always burn some, and so I was wanting to know which cookie pan would not burn the cookies. So we grabbed 5 pans, and we put 4 cookies on each pan, cooked them at the same time, same heat. The only thing that was different was the pan. My hypothesis was that the non-stick would do the best because it wouldn't stick to the pan, it wouldn't get right up on the heat. And my hypothesis was right. And the point, what I did on this project is that after they were done cooking, we would measure them, stick a toothpick in there to see if it was gooey or done. And yeah, and then we would eat them and see if we would think they were good, gooey, or burnt in the inside or stuff like that. And if I did this project again, I would love to try different cookies and different pans
different heat, different longer time, shorter time, stuff like that. And my hypothesis was right. I think I said that already. All right.
Hey, you're good. All right. Thank you for sharing. Excellent. Lots of great ideas that I think could be continuation projects with your new questions. I love it. Remember, we should always be asking each other some new questions to keep our research going. Excellent. All right, the next project. Oh, go ahead, Braxton. Did you want to say something? Nope. Okay.
Thank you.
Thank you so much. All right, our next project is Ripe on Time. I don't know what is going on. There we go.
Hi.
Right. Ah, there you are, Zeta. Okay, I'm going to pull up your quad chart and I will start your timer when you're ready.
Okay. Hi, the name of my project is Ripe on Time, and the reason that I did this project is because one day I was at my grandparents' house and I saw the Sims bananas wrapped, and I wanted to try and see what happened. My hypothesis is if wrap Sims bananas with plastic wrap or tinfoil, they'll preserve longer, release less ethylene gas, and ripen slower. I got 3 hands of 3 bananas, and with one hand I labeled it my control group, and I left it unseparated and unwrapped. With my other 2 hands, I labeled those as group 1, group 2, and I separated those 2 groups, and in both groups, 1 banana stem was left unwrapped, 1 banana stem was left wrapped with plastic wrap, and 1 banana stem was wrapped with tinfoil. I took the pictures of the bananas at the same time each day for every day. As you can see on my chart, my hypothesis was not supported by my data, and my control ripened the slowest. My chart also shows my control was in the underripe and barely ripe stage twice as long as the other groups. Group 1 was in the very ripe stage for the longest time, and group 2 was even in the overripe stage. The things I could have did different were I could have used the bananas as soon as they were picked, because I don't know how long they were at the store for before I bought them. I could have had a larger sample size to see if all the bananas did the same thing. I could have used non-organic bananas because I used organic bananas, and the non-organic bananas used pesticides, and the pesticides could make the banana ripen slower. And I could have refrigerated the bananas. And that's it. Thank you for listening.
Thank you so much for sharing. Excellent. Right. Our next project up is Toll House or My House? Which amount of flour is better? And our young researcher, are you ready, Sarah?
Yeah.
Great. Okay, let me get up your quad chart for you. And I can start your timer whenever you're ready.
I love cookies, and that's why for my science fair project, I decided to see if people liked less flour, more flour, or the normal amount of flour in their Toll House cookies. I thought they would like less flour because sometimes too much flour makes things not taste very good. The way I tested them was by giving them the cookie without them looking at it. Then they would tell me how much they liked it. My hypothesis was wrong. They liked the normal amount of cookie best. The reason might be because Toll House is very smart, so they might have already thought of doing this project, because since they made the first chocolate chip cookie, it'd have to be the best chocolate chip cookie so people would like it. And that's all.
All right, thank you so much for sharing. Okay, our next project up is Elephant Toothpaste. This is Colton and Colin. Were you all able to jump in?
We were.
Great. All right. Wonderful. Let me just pull up your quad chart for you, and I can start your timer whenever you are ready.
All right. We're from Lacewell Spray Elementary in Eden, and this is our project, Elephant Toothpaste. Our question was, which had a greater heat, the 6% hydrogen peroxide and the experiment with 3% hydrogen peroxide? Our hypothesis was if the 3% hydrogen peroxide produced more foam if the 6% hydrogen peroxide produces more foam than the 3%, then it will produce more heat. Our materials were 2 to 16 ounce bottles, 1/2 cup of 6% hydrogen peroxide, 1/2 cup of 3% hydrogen peroxide, food coloring, dry yeast, warm water, dish soap, 2 measuring cups, 2 mixing bowls, final tablespoon to measure, safety goggles. Our procedures were measure 1/2 cup of 3% and 1/2 cup of 6% hydrogen peroxide in measuring cups. Pour into separate 16-ounce bottles. Add 8 drops of food coloring into each 16-ounce bottle. Swish around. Add 1 tablespoon of dish soap to each 16-ounce bottle and mix it. Add 3 tablespoons of warm water to each glass mixing bowl. Then add 1 package of yeast to the mixing bowl and stir well. Put funnel in bottle. Pour in water/yeast mixture into each bottle. Record results. So the data that we got was that bottle 1, which had the 3% hydrogen peroxide, created a minimal flow up through the bottle. There was no noticeable amount of heat when you touched the foam. The foam was spin and had small bubbles. Bottle 2, however, had 6% hydrogen, which had the 6% hydrogen peroxide, created a 2-inch flow up over the bottle, and there was a noticeable amount of heat when you put your hand on the bottle, and it had big, thick bubbles on it too. Analysis. Bottle 2 on the left, which produced thicker and more foam than bottle 1, produced some foam, but it was gradual and didn't burst through like bottle 2. So our conclusion was that the 6% hydrogen peroxide produced more foam and therefore produced more heat than the 3% hydrogen peroxide. We were not able to measure the foam due to the way it came out for the bottle, but bottle 2 clearly showed a greater explosion when the yeast was added to 6% hydrogen peroxide. You could feel the heat whereas the reaction for bottle 1, there was little to no noticeable amount of heat coming from the bottle. The peroxide clearly has a reaction, but if we add more, we wondered if there would be a greater reaction, causing the flame to move higher / quicker for the bottle. That's all.
Excellent. Thank you so much for sharing. We're so glad you guys were able to make it on. All right. Our next project is Battery Showdown. This is an engineering and technology project. Charlie, are you ready?
Yes.
Okay, let me pull up your chart for you. And I'll start your timer when you start.
Hello, my name is Charlie Shaver, and my name and the name of my project is Battery Showdown. I wanted to see which battery brand lasted the longest, so I got 4 C alkaline batteries and Energizer, the DG Home generic brand, Duracell, and Everready. I thought that the Energizer would last the longest because of its marketing claims. I hooked each one of them up to a motor that ran a fan and recorded the times. After they all were done, the winner was Energizer. My hypothesis was correct, but all of the name brands were really close to having the same battery life. But then the generic DG Home brand had about an hour and a half shorter lifespan.
Wonderful. Thank you so much for sharing with us, Charlie. All right, before I move on, I just want to check with the group to see if Gabriel was able to join us. All right, if not, then that is our last research presentation for the afternoon. Congratulations and thank you all for being willing to share your research. We truly loved enjoying from you. The projects were amazing, learning from you. Your projects were amazing and we all learned from each other. So thank you. So that officially makes you NCSEF alumni. I hope that you were able to make some of the Spark Talks this morning and get to see what our alumni, that's my timer, get to see what our alumni have been doing and where they're at now. If you are interested in an alumni interview, you can just reach out to me via email at any time. I'd love to hear your story and more about your research. With that, we are going to just remind you, do not miss, today's events are closing, but do not miss tomorrow's awards ceremony. We're so excited to have you join us at 3 p.m. You can get that link in Symposium where you got this link. You will also get an email tonight from me in STEM Wizard with just the link for the awards ceremony in it. 3 p.m. tomorrow. So make sure you're somewhere where you can jump onto a Zoom and watch the awards ceremony. And that is what the awards look like this year. And then just make sure that you keep up with us. We love to hear from you, and we love to invite you to our events. Those are our Twitter, our Instagram, and our Facebook links. And so if you want to connect to us on any of those pieces or have your parents connect to us on any of those platforms, please do. And then I hope that you know how much your North Carolina voice and research matters. I did just drop in there a new documentary that featured some of the researchers from North Carolina this year. I hope you'll watch it and remember that always asking these great questions and sharing your research are the most important things as you work through the world and share. So with that, we are done for the day. Congratulations and great job to all of the researchers. We hope that you enjoyed your day, and we will be sending your certificates and medals through and your t-shirt to you through the school. So you will get that at school in the next couple of weeks. And with that, we are done for today. We'll see you tomorrow at 3 p.m. Congratulations again. Thank you all for sharing.